Renewable energy sources are those that are continuously replenished and have the sun as their primary origin. Solar energy that reaches the earth contributes to the creation and maintenance of life, while at the same time providing energy that can be utilized in various forms. So, as you can understand, today in this video, we will talk about solar radiation. The sun is a star with a mass of 2 times 10 to the power of 30 kilograms, a radius of 700,000 kilometers, and an age of 5 billion, and its expected lifespan is about the same number of years. Its surface temperature is estimated at 5,800 Kelvin, its core temperature at 14 million Kelvin, and the average distance to Earth is 150 million kilometers. For light to travel this distance at a speed of 300,000 kilometers per second, it takes about 8.5 minutes. The spectrum of the light emitted by the sun is usually likened to the radiation of a black body at a temperature of 5,800 Kelvin. At the Earth's surface, sunlight ultimately acquires a very irregular spectral distribution, which is due to selective absorption and scattering by the components of the atmosphere it passes through. The final form and energy of the solar radiation that reaches the Earth's surface depends on altitude, geographic location, the percentage of humidity in the atmosphere, the prevailing meteorological conditions, and the position of the sun in the sky. Conventionally, the passage of solar radiation, that is the length of the path that solar radiation travels through the atmosphere down to sea level, is characterized by a number called air mass, and it is calculated using the formula air mass equals 1 over the cosine of z, which is a dimensionless quantity, where z in degrees is the zenith angle, that is the angle between the solar rays and the direction of the zenith at that location. So, we can say that air mass indicates how many times longer the path of solar radiation through the atmosphere is compared to the vertical path. Some indicative values of solar radiation power. We can say that for air mass 1.5, which corresponds to a zenith angle of 48.19 degrees, the power is 830 watts per square meter. Components of solar radiation. As the sun's rays pass through the Earth's atmosphere, photons are scattered by water vapor, dust, smoke, and various particles. A portion of the scattered radiation reaches the Earth's surface, while the rest is diffused into space. A portion of the solar radiation is absorbed by certain components of the atmosphere, such as, for example, radiation being absorbed by ozone molecules. Finally, a third portion is reflected by the clouds and then diffused toward the ground. Thus, in every place on Earth, and of course on every solar collector, on every photovoltaic collector, 3 components of the incident solar radiation arrive: the direct or beam component B, the diffuse D, or the diffuse component reflected from the ground. Direct and diffuse radiation depend on the angle at which the sun's rays strike the surface, the solar elevation angle, the day of the year, and the condition of the atmosphere, such as humidity, aerosols, etc. Diffuse reflected radiation depends on the density of clouds and the morphology and color of the ground or its covering. The diffuse reflection coefficient is called albedo, and, of course, it depends on the type of surface. The total horizontal irradiance G, that is, the total radiation incident on a horizontal surface, is given by the following equation. G equals Vn times cosine of Z plus D in watts per square meter. Vn in watts per square meter is the direct normal irradiance, that is, the radiation on a surface oriented perpendicular to the sun's rays. D, also in watts per square meter, is the diffuse irradiance on the surface, and Z in degrees is the zenith angle. The direct irradiance Vn on a surface perpendicular to the sun's rays is always greater than the direct irradiance B on a horizontal surface. On the other hand, the diffuse irradiance D can be greater on a horizontal surface because it sees a larger portion of the sky dome. Thus, in areas with very little sunshine, it is preferable to take advantage of the maximum diffuse irradiance, which is why we place the photovoltaic panels in a horizontal position. Finally, the total radiation beyond the Earth, Gext, the solar constant of the Earth, is equal to 1,367 watts per square meter. Conclusion. If you want to be the engineer who offers solutions and not just products, then specialization is the only way. So if you want to learn about other aspects of photovoltaics, about the minimum distance between panels, about partial shading of one panel or another, and everything else related to the entire study, then this is the only way to be able to offer solutions. And if you're interested in learning how to do it correctly and offer photovoltaic solutions step by step with real tools and simulations, then take a look at our free courses. You can find them at the link below this video.
So subscribe and comment below. Tell us what you would like to learn next about engineering, buildings and energy systems. Personally, me and my team, we read every message, and your feedback shapes our next videos.